brief, well, not that brief perhaps, but a brief introduction to web technologies. And I'm sorry for running a little bit late with this session, guys. Nice to see you here. Hopefully, the rest of the dudes. Did I say that? Anyway, the rest of the gentlemen. Dudes, you can say dudes about people, Thomas. That's not right. Hey, dude. Actually, there was a guy that actually called me dude. He said, "Hey, dude." And I was like, "Am I in a Kenny Reeves movie? Do you remember this movie? There was the two guys, and they were like talking weird and say, "Hey, dude," all the time. Yeah. Anyway, but he called me dude. I've been called dude. So anyway, Web Technologies 101. This is part 1.5, I guess, because some of this stuff is actually known by you, gentlemen, already. So let's see if we can get this thing started and get a little bit smarter one way or another. All right. The the only true wisdom is in knowing you know nothing. Socrates, attributed to Socrates at least. So just relax, and that's okay. It's okay not to know. It's, however, prudent to try to become smarter if possible. But in this case, in this topic that we will be discussing today, there are so many moving parts. So it's worth repeating, and it's worth again scratching the surface to start with, and then moving into deeper or more complex topics later on. We need to get started with something. Now, what we will be looking at today is to briefly cover part one of this talk, which was, what web application development is about, front end versus back end. Focus more on web protocols and talk about the internet protocol, the hypertext transfer protocol, the URLs, which is the identifiers that people are using to access our service and our applications, and also how we could use them to pass in some data and stuff, right? And then we're going to just reiterate the importance of the request response cycle, which is really the fundamental of web development. And we're talking everything that is built upon web technologies, like the three main components: HTML, JavaScript, and CSS. And it's a variant of the client-server pattern, right? Where you have a client that requests some data from a server. The server serves that data by responding to the request, and the client does anything with it, right? And about statelessness and all of these kind of things. And then we're going to focus on something that is really, really important, and that's going to take more of our time, and that is the HTTP verbs. The HTTP protocol is built up of in a specific way, which is a series of rules of how communication can between the client and the server, or the front end and the back end, actually can be conducted. And the HTTP verbs are a part of the request that is being made, or a type of the request that is being made, and they are really, really important in all modern type applications that includes networking in one way or another. And then we're going to look into query strings and parameters, and we're going to take a little closer look at this very, very tiny little framework called Express.js that is built upon Node, that allows us to build web applications, whether we want to serve HTML, or if you want to build APIs, or whatever we want to do. Now, we all know about the definitions: website, servers, client, and browsers. Websites are just a collection of resources, of files stored on a computer. A server is a computer that is used to host these files. They are all these are computers that are connected to this huge network, this distributed network that we refer to as the internet in everyday language. And they can be found using specific type of addresses that in turn are also based on a specific protocol that is called IP, the Internet Protocol. Clients are also connected to the internet but they are not acting as servers, which means, quite logically, that servers are computers that serve files. They can respond to requests, and clients are just every other device that is connected to the computer, to the network. Sorry, uh, because they do not act as servers at all. It could be your laptop, um, it could be your mobile phone, it could be your refrigerator, or what have you, right? The more and more devices that are connected to the computer, to the network. Sorry. Browsers are pieces of software that you run on your client, and they help you to load those files that the servers are providing so that you can see them, consume the data or the information that is outputted on your screen. Uh, Now, there are things in our industry that happens on the front end, and there are things that happen on the back end. The front end of the website is the thing that the users can interact with, whereas so consequently the front end developer are the people who builds those user interfaces, and the back end of a website or a web application, I should rather say, is everything that happens on the server, in your application or in your database. There could be multiple things, and consequently, the backend developer is the person who builds and maintains that software. Now, I consider myself a full stack developer. That means that I can build both front ends and back ends, and that is exactly what I'm going to try to convey to you, so you can call yourself full stack developers, at least in the beginning of your career. And then if you want to focus on something specific, then you're free to do that. But everything we do in terms of learning and practicing by solving challenges is about both the front and the back end. And again, the internet. A quick thing about the distributed network. Now, the internet is made up of millions of interconnected computers, or other small networks, actually, that allow computers and other devices, as we already spoke, to communicate with each other. And all of that is made possible because there is a specific protocol that makes it possible. And that protocol is called the Internet Protocol. And a protocol is pretty much just a set of rules that you can use in order to communicate with devices, or that you use to send data across the network and to different clients. And so I've spoken about this with you guys at some point. What happens is quite magical, to be honest. Like, the Internet Protocol, what it is responsible for is to deliver the data in the form of small packages, or packets, as we call them. Not packages, packets. And what happens is that all your data that you want to transfer is divided or split into small chunks and thrown out through the internet. As I usually say, that it looks like confetti, and then they can magically align in the right order just before they reach their destination. That's pretty awesome, actually. And one very fundamental thing that comes into play is for those packets to know where they are supposed to go, and what the address is, where they come from, and where they are supposed to end up. So there are addressing methods built into the Internet Protocol that we use. And for you as developers, this is pretty important, because at least to have a basic understanding of this flow, without going into details and so on. That's more for the networking people and the security guys to understand, because all of this can be actually misused because of the fact that these are pretty open standards, and the communication is pretty easy to listen to, unless it's encrypted, of course. But the other player in this whole equation is the Hypertext Transfer Protocol, which is the protocol that normal people often use when they use internet. All of the websites and all of the applications are transferred to our browsers in the format of the HTTP protocol. But it is really important to understand that it's only one of many protocols that is used on the internet. It's not in any way is it the only guy in town. It might be the most popular guy in town, but it's not the only one, right? And the HTTP is built upon a very simple model where, again, the client makes a request to a server and waits for the server to respond. It's a client-server solution, and we are often using this expression that it's a request-response protocol. Very important to bear in mind, because quite often in modern development you are consuming data from an external resource using networking, using the internet protocol, and you have to wait for this data to actually return to you before you can do something with it. That goes without saying, but you'll be surprised how often you're going to slip on this. Now, let's talk a little bit about the Internet Protocol addresses, and we know them by its acronym IP address or IP number. And the IP number or IP address is an identifier for a device or a server and can contain hundreds of thousands of different ports. We spoke about ports a little bit before. It's a way into the machine or into the stack of it's actually the OSC layer that allows us to do something, to reroute certain traffic to different types of applications. But it's a little bit not really in scope for you guys at this point. So let's just settle for taking a closer look at the IP address. Also, I'm not going to go into too much of technical stuff at this point, but you all recognize IP addresses. You've seen them before. It is nothing new under the sun. However, IP addresses are an address. It's not a physical address, but it's an address that can identify a specific resource, but they are pretty inconvenient for people to deal with. You don't want to say, hey, visit me on 172.16.254.1. You want to use a different expression, and that's where we can start using URLs. But just a quick word about ports. Port number 80 or 8080 is actually used very often for web traffic, for internet traffic or HTTP requests, just so you know. So whenever you don't have to spell it out, it is most often port number 80 that is being used, or a default port for that kind of traffic. Now, locally, when you develop, you will start your web servers locally on your machines, and they will be assigned to a specific port, and those ports will be 3000, 3001, sometimes 4321 or something. They might be different ports, but you always need to communicate with your web server through a port. Now, URLs or URIs, as they are also called, I talked about this with you before, is also an acronym. It stands for Uniform Resource Locator or Uniform Resource Identifier. These are dealt with by domain name servers to translate and being translated into IP numbers, right? So they're mapped to a specific number in using DNS servers, and can help you as humans to access Aftonbladet, Expressen, ESPN, or whatever you want to read, instead of having to type in the IP number. So if we take a look at the anatomy of a URL, because URLs can be used to many other things than just identifying the resource or identifying the server. You can also identify the resource that you want to read or watch or access, but you can also send data through URLs. And this particular URL that points to this article, it's about two British politicians debating who would lead Britain in a better way. It's published on a publication called The Guardian, and in this case, uh, we would have to access this through the Guardian website through a URL. We will probably click our way down to this article and not type in the URL itself because the URL is extremely long, right? It's not an easy thing to do. Now, uh, what we can read out from this URL is that there is a protocol identifier. It's a secure socket layer HTTP request. There is a host name, host identifier. There is this 88 port. I ran a scan on this, so it's actually using 88. We do not have to spell it out because that's the default port on that server. And then you have a path to the specific resource. But then you have this question mark here with some parameters, key values. It says page and then equal and then some data. And this is a way for the browser to send off some data to that particular server and have it respond in one way or another. I do not know what this one actually means because I didn't write this one, but it's one way to spot these things. Now, the protocol is always set with letters before the colon and 2 forward slashes. And again, we spoke about HTTP, but there are others like the FTP mail to or GET or WebSocket protocol or DB or what have you. And then you have the host name, which is a simple one because it's the in this case the guardian.co.uk, but it could be your own server name that you can purchase and or whatever service you're using. And then you have the port, the path, and again the query string that passes out some parameters to your to your server. Now, what we want to take a look at now that we are finished with this particular run through is to say HTTP params, website. Let's see, not params, but RESTful APIs, REST part 1. This is the one, right? Let me just check so I didn't pull up the wrong presentation. And I want to go into not this. Damn, that's not the one. Sorry. We want to use RESTful APIs. Is this the one? No, that's not the one. Damn it. Sorry. Get request. Request continues from interactions. Oh, okay. Oh God. Are you shitting me? Where's my presentation? Oh. Hold on. I have it. It's called, just slips my mind, verbs, RESTful APIs, week 10 over REST, but I already, yeah, that's part 2. Is that the one? No, I already had this one up. No, yes, this is the one, right. And we want to get started here, right. So we're going to talk a little bit about the HTTP verbs now. That's the thing that we want to get into. I'm sorry about this delay. Now, the HTTP verbs are they are used to differentiate what sort of request you are making. The most common request that you are doing when you, let's say, open up your browser and you type in a URL and hit enter to navigate to whatever site, Facebook, whatever site you want to go to. That is a GET request. A GET request is a request that is used to read, or rather retrieve, a resource. So if you want to read a specific file, you make a GET request. Give me something. Now, it is also considered a safe request. It doesn't, there is no risk that you will modify any data with your request, and is also considered idempotent, which means that if you call it once, or if you call it multiple times, it will have the same effect. You understand? Which means that if you type in facebook.com and hit enter, you will get to the Facebook landing page. If you do it again, you will get the same thing over and over again. Do you understand? The end result of this request will be the same if it's done in the same manner without without passing in any data. So we are not modifying any data, and we are not we cannot count on the response being any different if we make this request over and over again. Now there's another type of requests, and these are the post requests. Post requests in HTTP are used to create a resource. So this post request is neither safe or idempotent, because if you make a post request to a server, then you modify the state of the database that is used underneath the hood. So quite often you add a new resource, you create something on the server. And also, if you make multiple requests with the same type of request, you will just keep on adding new resources, which means that it's not you cannot require this or expect that there will be the same end result. Let's say that you send off a post request saying, let's create a user named Kim. Okay, first time you send it off, a new user named Kim will be created and will be assigned an internal ID or whatever unique identifier the database requires of it. The second time you send the same request, another user with the same name of Kim will be created, but it will have another ID. The third time, a third user, and so on and so forth. So for every time you send off a post request, a new resource will be created, even if the data is the same. The database will be modified. So you modify the state of the database and you add a new resource. If multiple requests are made, the outcome will be multiple new resources. Okay. And then there is this type of request that is called put, and sometimes even patch. They are two different, but they are pretty much the same in one way or another. Yeah, you can consider them being the same. Now, the put request is not a safe operation, because you do modify the state of the database, because it is used to update a resource. So let's say that we return to this user Kim, right, that has been created. Let's say that we want to change his name to Svampen for some reason. Okay, so you make a put request, you identify the resource by this unique identifier, and you just send in one parameter saying name equals Svampen, and that will change the state of the database. So it's not a safe operation, but you can count on that if you do this multiple times, like let's update it to Svampen, let's update to Svampen, let's update to Svampen, the end result will be Svampen, right? So it is an idempotent method, because sending the same request multiple times will result in that change being made and nothing else, right? So that's the put request. And then finally we have a delete request, which is used in HTTP to remove or delete a resource that you identify through the URI. Now, on a philosophical level, you could say that delete operations are not safe. Of course, they are not, because you are actually changing the state of the database. But are they idempotent? Well, it depends how you look at it. Because if you call the delete method on a resource multiple times, the end result will be that the resource is deleted. Right? You can't kill what is already killed one way, But if you are trying to delete something that does not exist in the database, that will error out, and you will have problems instead. So it depends a little bit how you see it, but I would say that it is idempotent because the first call deletes this one. The second call, it doesn't really delete it because it's already deleted, so it just doesn't do anything at all in this case. One would argue. So you can use these functions on different type of operations that you want to do. And now I'm gonna exit this, and we're gonna take a look at our beloved Postman, which is a piece of application that allows us to make this kind of calls. And if you haven't downloaded Postman yet, I would definitely encourage you to do that. It started out, they recently celebrated some sort of anniversary, because I got a notification on, I think, like LinkedIn, that this guy started to build Postman like 10 years ago or something. But Postman.com, it's a fantastic tool for developing APIs and trying them out. And there are multiple things you can do. You can actually automate tests using Postman and so on. I don't use it for that personally. I use it to check out my APIs and what sort of response they do when I do some manual testing. Now, there is this fantastic little API that is built by some very generous people, and they allow us to create a testing ground for APIs, and they allow us to what they do is that they provide a method to mimic real responses for the get, post, put, and delete requests. So we're gonna try it out a little bit. So we can go to the documentation, and we can see that recres API /users and then question mark and some parameters can give us some response where we can actually list some users, right? So we're gonna, well, yeah, we're gonna do this in Postman rather than here. So let's do that. So we're gonna say recres /API users page 2. You see I have query parameters here that I can pass in. I pass this in from the URL, but this is definitely doable. And this is the response we are getting. We're getting a JSON object with a lot of users listed here, right? So if I pass in 1 here instead of 2, I will get a different set of users because we are paginating, as we call it, the data. Now I need to move myself away again because I shouldn't be here. I should be here. Right. I hear you, Kim. You good feedback on that sound. Good feedback. I read those things. So this is a GET request, and how do I make the GET request? Well, I can choose here in this pull-down menu between different types of requests, and we have on top GET, and we have post, put, patch, delete. But we have others, right? We have copy, head, options, link, and so on, right? These are not very often used in programming. I know that the options is actually pretty, it's used quite often by some authentication libraries and some other things, but we rarely use them ourselves, so we don't really have to talk about them. I just wanted to emphasize that those HTTP verbs that I'm talking about are not the only ones. There are many others that can come into play, and you shouldn't be horrified or terrified when you stumble upon them. Well, let's take a look at this API and see what sort of a post request can I do. Well, I can do a create action to this API, right? So I can do a post request to the pretty much same route, same URL. The only thing that is different is the parameter. We remove them, the query parameters, and we change the request type from a GET to a POST request. And then we pass in some parameters with the data that we actually want to create this user with, right? So I'm going to probably just use name in my case. So I'm going to go over to Postman, and I'm going to change this to a POST request, and I'm going to say, can I do query params here? I don't know. Let's try that. Let's say name. No, I don't want to do query params actually. I want to do params, cookies, settings, what sort of params do I want to do here? I don't want to do query params. Right, I want to do body, right. And I want to do form data. Right, form data. I think I want to do this. So I'm going to say name, and I'm going to say Thomas. And I'm going to send this off, and that wasn't that, so it wasn't raw binary graph URL encoded. Is that what I need to do? I didn't build that. Right, I didn't build that API, so I didn't know what sort of data I needed to pass in. But so I just pass in some data here as a parameter, as a post parameter, and what the API returns to me is that it was being created. And in the headers, which is also important, or is it in, no, it's not in headers. It says here. You see here, where I'm the thing that I'm highlighting, it says here that the status code that we got that we get back is 201, and the status code 201 means created. The status code 200 means that everything is okay, but 201 means created, and we just created this user, and it has an ID of 170, for instance, right? So let's say that we want to do a update request. So we're going to do a put request to the same API, but we're going to pass in 170, hopefully, and we're going to change the name to, hey, why not David? Let's see if that works. So if I now just do a GET request to this 170, let's see if we can retrieve that user. We can't, because it's not being persisted in this API. So let's see if we can retrieve user number 2. That is Janet Weaver. Okay, so let's see if we can do put to for this user, and we're going to change this to, and it's going to be first name, and we're going to say David here. David. Can we do that? Right. So we got the response with that this user has been updated. It's not being persisted because it's a test API. So even if we try to retrieve that user, we're still gonna get Janet, because that's the way this API is built. But we are making a put request. And then consequently, we can do a delete request to the same user, and that will return a 204, which means that it was deleted. And we just do this here. The URL doesn't change. We use the same URL. The only thing we are changing is the request type, and that we got a 204 no content, so there is nothing there anymore, right? So that's how you use these HTTP verbs for creating, updating, taking a look at, and deleting objects. And if you think about it, not really hard, actually, it's pretty straightforward. Everything in life can be created and discarded of, and it can be looked upon, and it can be changed or modified. That is the core of everything in object-oriented programming, and also everything in life. This glass was at some point manufactured, so it was created. It could be altered. I can paint it, I can break it, I can fill it with fluids, and I can do all sorts of things with this glass. I can delete it by throwing it away, right? And I can look at it. Oh, there's a glass here, right? And there isn't many other things I can do to it, if you think about it. And it's the same thing in programming. Every resource has a lifespan, and we call those things that we can do to these objects, those actions that we can perform on those objects, CRUD. It's an acronym, CRUD. Create, read, update, delete. Create, read, update, delete. And so if anybody wakes you up in the middle of the night, a drill instructor will say, hey Kim, what HTTP verb would you use for the create action? And you would answer?
What I would,
create action. What HTTP verb?
Post.
Yes, exactly. Post, yes.
Yeah.
And the delete action, David. What HTTP verb would you use for the delete action?
Was it remove?
No, delete. It's actually called delete.
Delete, yeah.
Yes. And so, Kim, the read action, taking a look at an object, what HTTP verb would you use for that?
To read. I don't know, to get it is like get?
To get, yes sir, exactly. And if you want to change something, David, what, in an object, what HTTP verb would you use for that?
Edit.
Put, of course.
Put. I said everything wrong, yeah. Thank you.
That's okay, that's okay. Now these are, so you will get into this. Now, this is basic stuff. You need to know all of this. If you want to change something on the server, put, or patch, actually.
Exactly.
If you want to take a look at it, it's a get request. If you want to create something, it's a post request. If you want to delete something, it's a delete request. And since we will be working a lot with networking in our applications, we will use those requests extensively. You build something in JavaScript or you build something in React, and then you make a call to a server somewhere that you will use any of these four requests. In your test environments, you will say, oh, I need to stub things out. I have to pretend that my server is responding with an answer, especially if you work with testing your front-end applications. Then you're going to have to stub out this type of requests. I will run a few examples of that later on in a different session, but actually before the bootcamp starts. So these are this is the gist of things that I had for you or had in store for you today. I cannot overemphasize how important HTTP verbs are, and there are 4 of them in play. If you can't learn them, then you're in deep trouble. Okay, and there's nothing in terms of, oh, it's a bit confusing or whatever. If you create something, you make a request to the server to create that. and you do that with a GET request. No, sorry, POST request. You see, I also fuck up, and so on and so forth. I don't want to even go down that alley now. And if you want to practice this, then you should get yourself a copy of Postman. You should go to the RecRes website, read up how you can use a fake API, and
sorry, what is it called?
RecRes. I will send you that in Slack.
I can't see that.
In
thank you.
1 second. There we go. Right. So that will allow you to practice this a few times, right? And again, if you're running into some issues with sending some data, the data type in the post request would be the body params XWWW form encoded. That's the one that you want to use in this particular API. The tricky part here is that different backend systems require you to modify your requests a little bit. But to start with, let's just get those verbs into your spine so you understand how they work. Okay? Good. So, Kim, did you pick up anything valuable in this session?
Yeah, the get push or yeah, get put, not push, put, get put, delete and
post,
yeah,
of course.
post, yeah.
Right. Good. You see, I'm a terrible
The
person. I'm torturing you.
rect address.
Right. David, did you pick up anything valuable?
Yes, of course. I didn't know this stuff, so it's very interesting. I just
Good.
have to find out how to use it. So it will be another
Right.
thing. Yep.
Right.
Thank you.
Now, so that's a very good question. How do we use this? We're not going to go into that too much because I don't want to spin up too much code. But in JS, there is this method called fetch. It's a function that is present in JavaScript nowadays. And to start with, you will do you will use fetch. I don't know if you guys know a little bit of jQuery. What used to be a revolutionary thing in jQuery was those AJAX calls, those asynchronous calls. They are networking, and they also did make use of the method. But without diving into jQuery, which is an old technology, the fetch is a promise-based networking function. So in this case, if you take a look at this, right? So we're doing a fetch request to http example.com, movie JSON or whatever, and then we are transforming that in those consequent 2 lines of code. We're transforming that into JSON. Doesn't matter. What does matter for today's discussion is this first line. Fetch is using the GET request out of the box, right? If you want to make a POST request, you do this. Look, there's a lot of things here happening, but if you read it line by line, we are doing fetch and then the URL, which is, it's a variable, and then you pass in a block and you say method, and in this case he's doing a POST request, and you get to choose between get, post, put, delete, which happens to be the same thing that I just spoke about, right? So you can tell fetch that, hey, I'm not doing a get request, I'm using a post request. And then you can send off some headers, some credentials, all of this stuff is above your pay grade at this point. But this one is interesting. The body is interesting. You're sending off some data to the server using a post request in this body attribute, and the server will receive it, and if it's configured properly, it will know what to do with that. But that's not your concern as a programmer unless you are building this thing, right? And then you have, let's see, probably right. So this is a simpler response, method post or put if you want to put, and then some headers in the body, right? I don't think that, well, here you actually have a put request. I don't think they show you an example of a delete request here. Let's see, there's a get request, so you can use that and so on, right? But and there's some other info about the headers and so on, right? But you don't have to deal with this at this point. I would definitely say that reading through this kind of information on the MDN web docs is a prudent thing to do. So fetch is used in vanilla JavaScript. What we will be using later on in React is Axios, which is another library that is an HTTP client. I always go to Axios to do what fetch does for me in vanilla JavaScript, but this one is actually a bit simpler to use later on, and you can see here that you have a very similar syntax. You're calling Axios instead of fetch, but then you can call .get on it, right? Which makes a get request. So consequently, if you want to do a post request, you say Axios.post or put, and so on and so forth, right? So that's a pretty neat way. So they actually call the function the same thing as the verb, right? And you can send off parameters in a nice way, either as query params as you do here, or as an object as the second argument, and so on, right? But we'll get to that later on. In order to be able to use these networking libraries, you need to understand the very basic of the HTTP verbs that we covered so extensively, and you will hear me hammer this into you many times moving forward, because it is really a fundamental piece of knowledge. You can use Axios asynchronously, with the async await keyword and so on. It's a pretty neat solution. All right, that pretty much does it for us now, people. Thank you very much for paying attention. I will make sure that make sure to practice this. Make sure to practice, and I see you later.
Yep.
Thank you.
Thank you.
Bye-bye.
Thank you.
Oh yeah. One thing. Was it? What time is it tomorrow?
1600.
Yeah, 1600. Okay.
1600.
We don't have anything in the morning, right?
Nope.
Tomorrow.
Nope.
Yeah.
Perfect. I have a lot of things to do.
Good stuff.
Right.
See you guys.
See you later. Bye-bye.
And for the brave souls at Twitch, thank you very much for paying attention. I see you later, guys. Cheers. And thank you, guys. Be cool, stay safe, and promise me to wash your hands and so on. All right. That does it for me. Thank you very much.